Latitude and longitude are part of a coordinate system used to locate any place on the Earth's surface. Of course, these are imaginary lines. The lines of latitude and longitude that we talk about in this video do not really exist. They are merely there for our reference. So let's get started. The equator is the 0 mark of latitude. It is the dividing line between the two hemispheres. So the equator divides the Earth into the northern hemisphere, so anything north of the equator, and the southern hemisphere, anything south of the equator. Lines of latitude run from the equator up to the north and south poles. We measure them in degrees north if they're above the equator and degrees south if they're below the equator. Lines of latitude are like rungs of a ladder. We can also think of them as flatitude, flat being horizontal lines. Lines of latitude are also parallel to one another, which means they never intersect. If you look at the diagram at the equator, that's the largest circle. As you move up north, the circles get smaller, but they never touch and they never intersect. There are some important lines of latitude that we will address throughout the year, and I'll show you where they are in your reference table in a moment. But the equator, the tropics of Cancer and Capricorn, the Arctic and Antarctic circles, North and South poles, and of course, Great Neck. Those are all important areas to keep track of when it comes to latitude. Moving on to longitude. Now, longitude runs top to bottom, and it divides the Earth into eastern and western halves. If you are on the left of the prime meridian, that's the western hemisphere. If you're on the right of the prime meridian, you're in the eastern hemisphere. Now, lines of longitude, as I said, run from top to bottom, and unlike the lines of latitude, these do intersect at the two poles. So in that case, we call them meridians. The prime meridian is our 0 mark, that's where we start counting, and every 15 degrees east or west of the prime meridian is a new line of longitude. You keep counting from 0 all the way till you get to 180. 180 would be on the opposite side of the prime meridian. When you get to 180, you start counting back down. Now, the most important lines of longitude to know are the prime meridian, which is the 0 mark, and the international date line. That's on the complete opposite side of the Earth from the prime meridian. And Great Neck, New York sits on the 74th meridian, west of the prime meridian. In our reference table, there are 3 examples of latitude and longitude referenced. So I just wanted to take a moment to talk about each one. So this is the surface ocean current maps, and I want to point out that you are given the latitudes that I said that you need to remember. So look, here's the equator, that's our 0 mark, the Tropic of Cancer, the Arctic Circle, and then the Southern Hemisphere Tropic of Capricorn and the Antarctic Circle. Tells you the actual locations and their directions, so you don't have to memorize those per se. They are represented here. I also want to take a moment and point out that this map is very different than all the other maps you've seen before. And the reason why is the prime meridian is actually somewhere over here. I know that's not a perfectly straight line, but that represents where the prime meridian is. The international date line is somewhere over here. So what that means is this is the western hemisphere. This is the eastern hemisphere. Most maps, it's reversed. The west is on the left and the east is on the right. But for this map and this map, western hemisphere is on the right and the eastern hemisphere is on the left. Just something to remember when you're looking at the reference table. If I were to ask you to find the coordinates of a location over here, you'd have to know that this is the latitude, but when I go to coordinate the longitude, it's going to be in the western hemisphere. So the other map that shows latitude and longitude is the Generalized Bedrock Geology of New York State. This map demonstrates something new, something that you probably haven't heard of. And that is that lines of latitude and longitude are measured in degrees, and degrees can be broken down into minutes. So I know minutes sounds like a unit of time. In this case, it's a unit of distance. So 1 whole degree equals 60 minutes, and 1 minute equals 60 seconds. You can't measure seconds on this particular map, but if you were to use a GPS and zoom into any location, it would measure to the nearest second. That would be the most detailed you could get to in terms of latitude and longitude. But for us, what I'm most concerned about is being able to use this map to measure to the nearest minute. So let me show you what I mean. You can see there's the 41st line of latitude north of the equator. So we call it 41 degrees north. It's outlined right there in yellow. And above it, that's 42 degrees north. Nice and easy, right? It's identified for me on this map. But what is also identified for me is the halfway mark. So that red line represents halfway between 41 degrees north and 42 degrees north. I could simply call it 41.5 degrees. I could. But I could also call it 41 degrees and 30 minutes. 1 whole degree equals 60 minutes. Halfway would be 30. I could do the same as I follow go further up the map. So 43 degrees north and halfway between 43 degrees and 42 would be 42 degrees and 30 minutes. And I think that's pretty simple. But what's not so easy is I asked you to figure out, well, what would be the number of minutes in this area? So what would be the location's latitude to the nearest minute? That's typically how that question's asked. So if I think about this, I know it has to be between 42 degrees and 30 minutes and 43 degrees. So it looks like it's halfway between 42 degrees, 30 minutes, and 43. And what's halfway between 30 and 60? What would be halfway? It would be about 45. So the best answer here would be something like 42 degrees and 45 minutes. And that would be an approximation of the latitude of that location. This also works for longitude. All right, now longitude runs top to bottom. We measure it east and west. Every location in New York State is going to be in the western hemisphere. So here's 77 degrees west. Here's 77 degrees and 30 minutes west. Here's 78 degrees west. So one tricky thing is we're counting kind of backwards, like going backwards on another number line, because the numbers are going higher and higher the further west I go, because I'm approaching the international date line. So as I keep going to the left, now this is 79 degrees west, this would be 78 degrees and 30 minutes. That's it for now. Thanks for watching.